Hi teachers, my name is Tracy Barnett and this is a little video on how to teach long division using base 10 blocks to help your students build their conceptual knowledge. It's important that we build the concept knowledge behind the algorithm. Building new concepts in the minds of learners is essential for the transfer of knowledge and skills, and that's the whole point, is we want them to be able to transfer their knowledge to work real world problems. It is important for students to understand more than just the procedural fluency. We want them to understand what they are actually doing within the place values and have a conceptual understanding. This will help them connect the operations to real world problems. So we have to go beyond the algorithm. They need to understand the process behind the algorithm and why the algorithm works.
Okay, so I have this problem. I have my base 10 blocks, I have a drawing, and I have the numbers, and I'm going to relate these all together. But this is the problem I'm doing, 356 divided by 2. I'm going to show you how the algorithm relates to the drawing, which goes back to the base 10 blocks. Now, as a teacher, you can choose, I would do this with the base 10 blocks in the drawing and then add the numbers, but it's up to you. I'm going to show you all three so you can make sense of it. All right, so I have my base 10 blocks. And I have 300, which 1, 2, 300, which is 3 flats. 1, 2, 3, 4, 5, 5 rods, which is 50. 1, 2, 3, 4, 5, 6, and 6 little ones. Here I have the same thing. 1, 2, 3 flats. 1, 2, 3, 4, 5 um, rods, and 1, 2, 3, 4, 5, 6. Okay, and I'm dividing them all by my divisor, which is 2. Okay. So, first thing I let students know is that division works backwards than what you're used to. Most of the time, we start from the lowest place value with addition and subtraction. In division, you actually start with the highest place value. You're dividing the highest place value first. So the highest place value I'm dividing is 100. So I look at my hundreds. How many sets of 100 do I have? I have 3. How many do I need to make a group? I need only 2 to make a group. So basically, I can make 2. So I can take 2 of these and make a group of 2, right? And so this means I've made one group of 2. So when I divide 2 into 3, I will get 1. Now, I put that there. I still do the subtraction, which 1 times 2 is 2 because I took it away and I made a group. So I took it away and made a group. So that's why I subtract it. And I take this and I get a remainder of 1. So I have 1. Well, what do we do when we have remainders? We have to move them into the lower place value. So what does this mean? If I'm moving 100 into a 10, if I'm moving this 100 into the tens, if I'm moving this 100, how many tens are inside of this 100? 10. So I will switch it out. And this is the important part. I'm switching it down. So I'm sorry, I dropped it. I'm switching it down. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 10 tens to trade out. So I trade out and I move them into the tens place. Same thing what I'm going to do here. In my drawing, I'm going to do the same thing. I'm going to mark it out and put an arrow down, and I'm going to take it and make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Now I have 10. Same thing here. I'm going to take this and I'm going to just bring my 10 place out. So now I'm actually have how many? How many tens do I actually have? I have 15. If I count all of them in my place value blocks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15. Same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15. So then I do the same thing. How many groups of 2 can I make with 15? Well, if I go, I can draw it. I can start making groups of 2 with my thing. So let's see. 1, 2, 3, 4, 5, 6, 7. I can make 7 whole groups of 2. But if you want to do the math involved, you can have them group it if you want. And this is just to get the idea of what you're doing. You can have them group it, and they're going to get 7. And you can also say what times, if we want to do it the quick way, we can put our 2's out to the side here. 2, 4, 6, 8, 10, 12, 14. 16, 18, and you'll have to go to 9. Okay, and then you can say how close. Oh, well, why is that? It's I have 14. I made it took 14, right? Why? Because I made how many groups? 7. Because 7 times 2 is 14. So then I made 7 whole groups. So I would put a 7 up here. And if you see, I made 7 whole groups. 1, 2, 3, 4, 5, 6, 7. You can count them. 1, 2, 3, 4, 5, 6, 7. Okay. Then same question. If I minus my 14, because 7 times 2 is 14, I subtract it, I get 1 left over. What happens to that 110? Where does it have to go? It has to go to the ones. What happens to a 10 when you put it in the ones place? It becomes a bunch of ones, right? So then you show them. Let me give my groups away, because that's my 7 groups, and they go away because I moved them up here, right, into the quotient. And then I have this 10 that I need to get rid of, because I'm dealing with just ones now, because I'm in the ones place. And I have my 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? And I needed one more. Okay, so I have 16 now. And if I bring this down just like I do in the algorithm, I have 16. Okay? So same thing. I have this little 1 hanging out here. This little 10 hanging out here, and I bring it down to the ones place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I ask myself the same question. How many groups of 2 can I make with 16? Well, if I do the math over here, they should by now have some kind of idea, at least some of your kids. You can make 8, because 7 times 2 8 times 2 equals 16, right? And so you can make 8 groups, or you can have the kids that need to make the groups. 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Or you can have them do it 1, 2, 3, 4, 5, 6, 7, 8. And they can see that's how many groups they made. I don't have anything left over. I made all of the groups. So this is what I would do. Minus 16, I used all of them, so I have a remainder of 0. This is how the base 10 blocks, the drawing, and the algorithm all relate. And I wanted to kind of give you an idea of how to do that. And you can take your kids. Now, would I do this in one lesson? I might. Would I maybe do just the base 10 blocks in the algorithm and then take it to the drawing? That's up to you and your students. But I wanted you to have a conceptual knowledge of how to teach this with the base 10 blocks. Thank you very much for joining me.